So we'll talk to you about the challenge and some context and then what we did. So I'm at the Software Engineering Institute, and I'm lucky enough to be able to do a mix of research and consulting. And so this particular engagement was a little bit more on the consulting side, but a little bit of research aspect to it, because this challenge wasn't one of these things that we've got sort of cookie cutter out of the box. And what we did was develop something called an architecture integration workshop, which is a fancy name for some just-in-time training that I will describe. Tell you what we did, and then take a little retrospective look at what worked, what didn't, and why we think it worked, right? What are the sort of underlying success contributions that we would need. This project was a little bit different. A lot of times as a consultant, you come in, you do something, and you leave, and you hope it was useful, but you're never quite sure. In this case, we had the opportunity to come back later and see the results of our work. And so we've got some evidence that it actually did work, and wrap up with some conclusions. So here's the joke. The radio astronomer and the architect walk into the bar, and the astronomer says, "We're building a really big telescope, and I'm worried I can't sleep all day." And don't you mean sleep all night? No, I'm an astronomer. We work all night, sleep all day. Right? So what's worried? Lots of subsystems, as Greg described. This is a system that's being built by a consortium of consortia. So each element is funded by a national science organization or a university. And people are kind of working for their university doing this stuff. And it's all got to come together at the end. But nobody's really paying anyone to do it. And everybody's just sort of getting paid. But it's not like one organization has a contract with another. So in some ways, it's a little bit like open source. And you'd hope that there's a benevolent dictator. And so lots of subsystems, different teams spread across the world, not much authority. But in this case, the astronomer in charge did have a little bit of leverage in that there's a critical design review. And he had to, his group had to accept the designs, the architectures. So that was the one piece of leverage. He couldn't tell people what to do, but he could tell them that they did it wrong. And so he needed visibility into pieces come together, and yeah, we can help you with that. Better documentation, sure, but yeah, we don't have much time or money. So heard that before, right? So it's a really big telescope. The quote from their prospectus, one of the most visionary and ambitious projects, ultimately the largest scientific instrument on Earth, both in scale, physically, and volume of data. It's 2 antenna arrays with each having a supercomputing center attached to it. It's going to live for 50 years, right? And it is managed from global headquarters at Jodrell Bank in the United Kingdom. It's a little place just south of Manchester out in the country. So, as I said, 2 arrays. There's a mid-frequency array, a bunch of antenna dishes, and you can point the dishes, but then through the magic of signal processing, you can combine all of those to make one really big antenna. All right? And they're spread out across the high desert in South Africa. Not built yet, so this is the artist's rendition of what it will look like. And so physically big, spread over miles, tens of miles of area. All right. About 200 dishes. Raw data output 2 terabytes per second. It's a little hard to read there, but that's 2 terabytes per second, 62 exabytes per year. Right. A little bit of data to worry about. Right. Enough to fill 340,000 average laptops a day. They're trying to sell this to the public and explain the magnitude of it. So yeah, I don't know about you, but my father doesn't understand terabytes. If I explain laptops, he can imagine that. So this is oriented towards the layman. Right? So that's the one. The other array is the low frequency array, which is a bunch of these dipoles, just regular single antennas, 130,000 of them that need to be controlled. So this is a SCADA system, system control and data acquisition kinds of architecture, 130,000 nodes. And this array is even bigger, 157 terabytes per second, 4.9 zettabytes per year, a little bit of data. Right? In this case, enough to fill 35,000 DVDs a second. Yeah. Right. So, you think they need some software? Think they need some software architecture? Yeah. There are big antennas, but nothing quite like this, right? So the context, constraints. They said, don't have a lot of time, don't have a lot of money. We're going to bring people together from around the world. We will give you 1 week with them in SKA headquarters, SKA headquarters at Jodrell Bank. Had very limited funding for preparation. The overall project, this Square Kilometre Array, this phase of it is a little bit waterfallish. Right? And if you think about it, right, this is a very expensive project. They're talking about 750 million euros to build it. Right? And so they want to do a fair amount of design. There's a fair amount of logistics. You got to go acquire land. You got to think about how are you going to build all of these antennas. So you got to think about manufacturing concerns. And from a software point of view, they wanted a software design before they go and commit to building it. Right? It's going to be around for 50 years. Right? So if you were at the 101 boot camp the other night, right, EPEC talked about where's the sweet spot on the curve, how much architecture should you do up front? Well, if you're going to spend that much money for 50 years, a little bit upfront architecture, not a bad thing. Right? And they wanted to do enough design here to demonstrate an acceptable level of construction risk. And it's where they use the term construction for both the physical stuff and the software. We're going to go construct some software. The good news is when they think about construction, they're talking about using agile methods and safe. And so although this is a little waterfallish, once they turn the key and start developing software, it's going to be rational in the way they do it. Okay. Participants, we had 30 people coming from 16 institutes across 8 different countries. So this was from all over the world, people coming together. And there were people with lots of domain knowledge. They were all astronomers, there's 2 kinds of astronomers. There's the ones that build equipment and instruments and the ones that look through the instrument. And these were all equipment builder astronomers. But still, a lot of domain knowledge, had written a lot of software, but nothing at this scale, right? So a lot of coders, a lot of hackers, a lot of scripters, but not a lot of hands-on or formal software engineering training. A very strong system engineering culture. So they have a requirements breakdown, level 1 requirements, level 2 requirements, breaking it down, decomposing, traceability. It's a very strong culture around that, and a very strong project management capability. So they had some things going for them. And so that was the participant side, and from our side, there were 2 of us, myself and Neil Ernst, who was at the SEI at the time and has gone on to some other things. So what did we do? We said, let's build this thing called an architecture integration workshop. We want to understand what's it going to take to have confidence that all these pieces are going to fit together. So architecture integration, how we're going to integrate these architectures. We took an agile mindset to creating the workshop. We said, okay, you ain't going to need it. Let's do just enough learning. Right? Let's not trot out our curriculum and our 2-day software architecture principles and practices class where we're going to explain to you what is architecture and why it's good and how it's useful. These people were kind of down that road already. And our documentation class where we can teach you a lot about documentation, but these people wanted to document this system right now, right? So we were going to take that material, remix it, reuse it, pull out the pieces we needed to put together for this particular set of people on this system. And the approach we took was, let's motivate the need for documentation by doing some analysis. So teach you a little bit of analysis techniques. Let's find some problems that need to get solved. And then let's create documentation to help us solve those problems. Okay? And let's not create abstract documentation. Let's not use the ATM example. Let's not use the web app example. Let's use this system as the example. So we're going to teach you something, and then you're going to go off and do it for your system. Okay. All right. And so it was a 7-day workshop. That was 7 straight days, Monday to Sunday. And I wasn't able to put any pictures in here. The SEI gets a little funny about photos and who's in them. And I couldn't get everyone's permission. But Jodrell Bank is out in the country. And there's a little village there that has 2 hotels, and we filled one of them with all of these participants. And so every morning, a bus would come, and it was like going to school or going to camp, and we would all file onto the bus, and the bus would bring us to the site, and we would work from about 8:30 in the morning until 6 o'clock at night, and then the bus would take us back to the hotel. So it was very team building on one hand. It was also the middle of January in northeast England, so the sun wasn't up in the morning and it had already set in the evening. So this was a pretty intense 7-day exercise. And as I'll say later, the participants were amazingly engaged. There was nobody multitasking, doing email throughout these 7 days, and they stuck with it. We had to drag people out the door at the end, kick them out. So it was an unusually high-quality group. But what did we do? We started, this is the exact agenda that we used there. We did a mission thread analysis. We traced through how do you set up the telescope for an observation and start the observation and track the telescope during the observation and then end the observation and process the data. It seemed like a pretty straightforward question, given where they were. Turned out to be difficult to ask. We found lots of places where a little bit of documentation would help. And because there was no documentation, there was this, everything had to start from the beginning. Because no one would, nobody could say, well, this black box over there did something and sent it to us. Because the people that own that black box said, no, let me tell you, before us there's this other black box. And those people were there and they said, no, there's this other black box. And it started off with, 1 billion years ago, a star exploded and light came out. And we, every discussion of the telescope started like, I mean, you had to go back to, and they're all scientists, so, you can't just say a star. No, it's not a star, it's a type 3 pulsar. So it was interesting getting through the mission thread analysis. Give you some lessons learned on that. Looked at some commonalities, variabilities along the findings, and then we said, okay, let's do some learning, quality attributes, right? We talked a lot about function as we traced this through. Now let's talk about quality attributes. Did some learning, went and then did some quality attribute scenarios, right? So let's get concrete about the system. And once we had that, we talked a little bit about documentation, did another mission thread analysis, and now we were just able to start applying some of the documentation approaches to clarifying as we went through. Talked about more documentation, interface, and behavior, and then started to wrap things up. Let's prioritize the quality attribute findings. Let's look at the mission thread coverage. few of the people did leave on Friday, but most of them stuck around. And then we took 2 days of working sessions to start creating the documentation we would need in order to do the analysis that we were going to be able to satisfy these mission threads. All right. And so what worked? This idea of just-in-time training, at least for my experience consulting, was a new thing. Usually we tend to think of packaged training. We're going to give you what we know, and you know, it's usually cheaper and easier for everybody, but it may not exactly deliver the value. And so here this really delivered the value. And this sequence of, you know, analysis, identify a problem, do some training, and then practice with some coaching worked well. And doing it on the target system was an interesting way to do it. And what did we produce? So we produced 2 mission threads with some variations on them. So they had that to take away. So something immediately useful. All the quality attribute scenarios, again, immediately useful. And they were able to produce design and documentation for 3 views. So they were able to take a module view of how some of the key parts of the system get decomposed. They did a component connector view that traced some of the timing critical path. And they did an allocation view to finally reconcile how this stuff gets spread over 2 continents and, you know, many square miles of desert. So physically, how does it get laid out? So what didn't work? As I said, defining a mission thread with such a large group was really cumbersome. And so it's the kind of thing, if you've done any sort of business thread or mission thread analysis in a system of systems, or if you're doing system integration where you're going to take an end-to-end thread of you know, business system, it might be from order to cash. So an order comes in, and how do we do all the fulfillment and processing and billing and eventually or how does a user make a request and end up getting product shipped back to them, right? So tracing all the way through the system. The analysis of that, if you haven't already defined it, is difficult with a big group of people. And so that was one issue. Talked about this issue about the group not being comfortable abstracting any part of the system. Couldn't call anything a black box. You had to drill in. I think the symptom of diversity, symptom of the scientific background, I also think it was a symptom of not having any documentation. And so you weren't exactly sure, and you had to defer to the person sitting next to you, and they had to defer to the person sitting next to them. And you had to trace it all the way back to energy entered the antenna from a pulsar, type 2 pulsar, right? And so everything had to go back to the beginning, and that was challenging. That's kind of architectural things. Some sort of general consulting facilitation things. Facilitation is hard in a big, diverse group. And you've got to strike this balance of individuals, some are faster, some are slower. And how do you keep things moving without offending people? And that's certainly a skill that you need to work on. We didn't handle that as well as we could have on the first day or two and got some feedback we're able to correct. But it's something that at least checking periodically, making sure that everybody's with you. 7 straight days is a long time to work with no downtime. And the other, I don't know how many of you that do consulting, there's a point where you start having opinions, right? I see Dan nodding, yeah. And that's a dangerous thing. So if you are doing consulting and you're trying to coach someone, you've got to be self-aware and recognize when you may know more or you may know different, but it's not your system. And And shifting from coaching, helping somebody solve the problem, to solving it for them or telling them how they should have solved it is a tricky thing. So some lessons learned. Why did it work? When I go back through it, if you're going to do this sort of thing, what do you want to be sure you have in advance? Engaged people. This was an extremely high quality group of people who were willing to come in and learn. I think they had reached that tipping point where they knew they had to do something different. They weren't quite sure what it was, and they were happy to get help. So that was good. Context knowledge. Neil, who did the work with me, had just done a bunch of things with scientific computing, and so he kind of understood some of that dimension of it. Domain knowledge, I knew a little bit about phased array radars, which are kind of similar to these antennas from earlier in my career. That helped hugely to be able to walk in with a little bit of domain knowledge. Flexibility. We brought a lot of stuff with us, and were able to kind of pull out the right set of slides just in time and get it up and start presenting it. Physical fitness, 7 days on your feet is tough, and outstanding logistical support. We never ate so well for 7 days. They were bringing in lunch that was just astounding every day, but everything, right? And so as everyone that was there was able to focus on how are we going to solve this technical set of questions, and nobody had to worry about who's going to order lunch or what time the bus is going to be there or how are we getting to the airport. It was just all this magic happened around us. So, so some things that, if you're going to do this kind of thing, keep in mind. So then, fast forward 1 year. They said, critical design review, we got to get ready for it. And then the critical design review came, and they said, would you come back and help us do the architecture evaluation? Right, decide, is this construction risk acceptable? We used an ATAM style scenario-based evaluation. We did some tailoring. That'll be the subject of another talk, maybe next year. But the key takeaway that we had was the documentation artifacts. The team had gone off and built a bunch of documentation to support this evaluation. It was good. We were able to analyze about 9 scenarios over 14 hours. So if you do this kind of scenario analysis, that's a pretty good coverage, pretty good velocity. The documentation facilitated efficient and detailed discussion. Right? And this is sort of a qualitative measurement. Often when you do this architecture evaluation, you reach a point where you just all agree that we don't have enough documentation to be able to proceed. Right? We kind of get to this point and it's all getting kind of fuzzy. And here we were able to keep going. And the kinds of issues we were finding were deep and detailed. So, and I think that speaks to the quality of the documentation. Right? If you don't have high quality documentation, you kind of end up finding superficial issues, superficial risks. Here they were good, and they were narrow. They weren't these sort of broad brush things of it looks like your performance isn't good enough. It was on this critical path, it's not good enough, and it's not good enough because of this particular transaction that you're building. So. And the other thing we found was that the teams, when they were doing their architecture design, used a scenario-driven design approach. So they built quality attribute scenarios, and so we were able to tailor the evaluation process to feed that forward and take advantage of it. And as I said, come back next year for that one. So the conclusion, which we weren't sure going into this if it was going to work, but a little bit, a week's worth of just-in-time hands-on training can have a big impact in the right context. And what's the right context? You got an organization that wants it. You got architects that are open to taking these new approaches. The approach solves visible problems, so you're immediately producing value. And the architects have experience to see that value, right? they can see that it's helping. It's hard work for everybody, and in retrospect, you know, if we had been able to stay involved over that year, I think the outcome would have been even better. You know, if anything, some of their documentation was over-documented. There were places where they provided a lot more than they needed, and we would have been able to help them tailor that back. But thanks to everybody that was involved with it. Nick Reeves was the radio astronomer that walked into the bar with me, and he's the head of computing and software at the Square Kilometre Array. The 30 attendees, and Neil, who is with us in spirit from Canada. So, thank you.
We have time for a few questions. Yeah. One place one.
So you decided to use as examples during the workshop an actual example from the system to be built. Yeah?
Yes.
Based also on our experience, this increased some of the negative feedback that you have, that it's hard for the people to abstract.
Yes.
And that they go into the details of
yeah.
it. But you took this decision deliberately, I guess. Mm-hmm. Would you do it the same way the next time?
I would, yes, I would. I think that by using the examples from the system, it feeds into showing value immediately, right? It's not some academic abstract exercise, it's my system. And in this case, you know, these people, they didn't want to learn how to architect software. They were here to build a telescope, right? And if you're in that kind of environment where, you know, and they build one of these every 50 years, so it's not like knowing how to do it helps them. They just got to get it done, right? And so if you're in that kind of environment, using the system helps. It's risky, right? I mean, we went in there and we were, it's improvisation, right? You know, walking on a tightrope kind of thing. And it certainly could have failed badly. We had committed to be there for 7 days, and if it failed badly at the beginning, we had 7 days of slogging to get through. But we were able to make it work. So you know, I think everybody was flexible. That was a big part of it. So.